All right, let's take a look at covalent bonding. Everything we've done so far, the Lewis structures, the bonding with the Lewis structures, and the shapes and structural formulas for covalent substances. We'll start off with the Lewis structure, bonding. In the first one up here, we have carbon and sulfur. So what we have to do is look at the Lewis structures for both carbon and sulfur to try to figure out which of those two atoms best fits in the center of our atom. Most of these, we're dealing with small substances. We're dealing with small molecules. They'll pretty much be a central atom that everything else is connected to. The one that ends up being in the middle is the one that can make the most bonds. And the Lewis structure will tell us which substance that is. The Lewis structure for carbon has 4 single dots. The Lewis structure for sulfur has 6 dots. That leaves us with only 2 singles. These single dots tell us how many bonds these two elements can make, and what they're telling us is that carbon can make 4 bonds and sulfur can make only 2. So the one that makes the most bonds, the carbon in this case, ends up being the atom that we have to put in the center. Start with it. Carbon with its 4 valence electrons. Arrange the sulfurs around the carbon. Now we can twist and turn this Lewis structure for sulfur clockwise or counterclockwise, any way we want it. There's no rule that says the single dot has to be on the bottom and on the left. It can be on the top and on the right, which is probably a better place to put it in this particular scenario. It lines it up better with the single dots on the carbon. Essentially all we've done here is turned this configuration clockwise a couple of spaces. We've rotated it a little bit just to line up those single dots a little better. On this side, this one works best because again it's going to line those single dots up better with the dots on the carbon. Now the way I want you to show covalent bonding is by circling the pairs of shared electrons. So basically connect the dots. We can share those 2 electrons to make a covalent bond. We can share those 2 electrons to make a covalent bond. That sulfur and carbon are connected by 2 shared pairs of electrons, or what we call a double bond. Same thing happens on the other side. We connect the single dots, find them partners. Again, the carbon and the sulfur are connected by 2 sets of shared electrons, or 2 shared pairs. That is a double bond. That's what I want the Lewis structures to look like as far as the covalent bonding is concerned. Number of atoms just goes back to the formula or the Lewis structure we've drawn. There are 3 total atoms. We need that information because when it comes time to figure out the shape, the bond angle and all that, there's 2 factors that are important. The number of atoms and whether or not you have unshared electrons. Again, the number of atoms is simply a matter of going back and looking at the formula. 1 carbon, 2 sulfurs, total of 3. We're just counting what we've got here. 1, 2, 3. The unshared electron part, that's a little bit more complicated. We have to look at the middle atom, and only the middle atom, to see if we shared all of its electrons. Carbon is the middle atom in this case. And if we take a look back at that carbon, we can see that every single dot that it had, all 4 of them have been shared. So there are no unshared electrons. This is the information that we need to determine the shape. We need to know the number of electrons, and we need to know whether or not we have unshared electrons on the middle atom. Only the middle atom. We go back to the table we did in class yesterday. Again, we have 2 rows for 3 atoms. The difference being whether or not we have unshared electrons. In this case, no unshared electrons. Bond angle is 180 degrees. It's going to be linear. The shape is going to look something like that with all the atoms arranged in a row. The 180 degrees is the separation between the 2, or the 3 atoms as in this case, We want to get the greatest degree of separation we can. Valence shell electron pair repulsion theory tells us these electron clouds and these atoms have to be as far away from each other as possible. 180 degrees, opposite sides of the circle, is as far apart as they can get. Again, we're going to arrange them all in a straight line. So sulfur, carbon, sulfur. We're going to get rid of these extra dots. We don't need those. And we're going to replace these circles with dashes. We have 2 circles between this sulfur and this carbon, so we replace that with 2 dashes to represent the double bond. And the same thing happens over here. We've got 2 circles between the carbon and the sulfur, so again we replace that with a double dash. The 3 atom molecules, again, a little tricky. You got to look at those central atoms, figure out if you have unshared electrons or not. Let me jump down to this one. It's got 3 atoms again, 1 oxygen and 2 fluorines. Oxygen's Lewis structure looks like that, 2 single dots. Fluorines has only 1 single dot. So again, the one that has the most single dots is the one that has to go in the center. So the oxygen has to go in the center. Like I said, most of these molecules are going to have a center atom that everything else is attached to. The center atom has to be the one that makes the most bonds. The single dots tell us how many bonds it can make. Oxygen has 2 single dots, it makes 2 bonds. Fluorine has 1 single dot, it can only make 1 bond. Start with the center atom. And align up your fluorines with the single dots. And again, we can rotate this any way we want to. It makes sense to put the single dot over on the right side this time so it lines up with the oxygen. And we can share that pair. And then when we get to this bottom one, it makes sense to put the single dot on top. Because again, we want to share these single dots like so. That is the Lewis structure model for the bonding. 3 atoms again. But this time when we look at that central atom, we have not shared all of its electrons. There are 2 pairs of electrons here that have not been shared. So it's a yes in this column. Yes, we have unshared electrons. And again, if you take a look at the 2, you can see the difference. Carbon, all the dots were circled, no unshared electrons. Oxygen, we have these 4 dots that weren't circled. We do have unshared electrons. Go back to our table. 3 atoms with unshared electrons. Bond angle is something less than 109.5 degrees. Now the actual degrees of separation depend on the actual elements. So all we're going to say is less than 109.5. The shape is bent. It looks like this. The one in the middle, the 2 on the ends have been deflected down. Basically, the unshared electrons are here on top, and they push those 2 atoms on the end downward. So again, the shape is called bent. The bond angle is less than 109.5 degrees. The shape being bent, we put the oxygen in the middle. The sulfurs are going to go down below it, deflected a little bit. Sulfur's fluorine. Looking at the one above it. Sulfur was the last example I did. Fluorine this time. The fluorines are going to be deflected down a little bit. There's only a single circle between the fluorine and the oxygen. So it's a single dash. Again, only a single circle between the oxygen and fluorine. So again, a single dash. The angle here should be about 109.5 degrees. Now I'm not going to get out a protractor on tests and check it. I just need to make sure it doesn't look linear, that you definitely made that molecule look bent. The other ones that tend to be a challenge are the 4-atom molecules, the ones that have the possibility of being either trigonal, planar, or pyramidal. Because again, it comes down to unshared electrons. Let's take a look at NF3. When we examine the Lewis structures, nitrogen's got 3 single dots. Again, fluorine has only 1. The one with the most single dots can make the most bonds. That's the one that has to go in the center. So start with it. And then connect the fluorines up to it. And again, rearrange that configuration, that Lewis structure where you have to kind of line your dots up to make your Lewis structure bonding neater, more compact, less of a mess, more like the actual shape in the end. You draw these things all over the place, you draw them all the same way, you end up with these big looping circles that go all over the place. We're going to try to avoid that by making everything nice and neat and straight, lining up the single dots so we don't have to make giant circles. 4 atoms, 1 nitrogen, 3 fluorines, 1, 2, 3, 4 atoms. That's the simple part. Again, for the unshared electron part, we have to focus in on only the middle atom. The only thing that matters is the nitrogen. And we have to look to see whether or not we've circled all the electrons. Let's just cover them up there. And you see on top there, we didn't circle those 2 electrons. Because we didn't circle those 2 electrons, we have unshareds. If everything had been circled, then they know that. But again, we've got these 2 electrons on top. I don't know how that ended up there. I must have added an extra dot or something when I was doing the fluorine. But those are our unshared electrons there. Go back to our table. Again, you see 2 rows for 4. No unshared electrons, yes unshared electrons. We are down here on the yes. 109.5 degrees or so is the angle again. Pyramidal is what we call the shape. And as I said, it's a 3-dimensional shape on a 2-dimensional board. This is a tiny little pyramid. We draw these legs bent downward by the unshared electrons. Looks something like this. Draw the center atom first. Drawing your sticks. And again, it's like the legs of a tripod. These 2 are going back into the board. This one's coming out of the board. It is a 3-dimensional shape. Put the other atoms around it. I drew single sticks because I have single circles between all the N's and the F's. 5-atom molecules, very straightforward. They can only be one shape. To get a 5-atom molecule, you're going to have to use up all the electrons available for bonding. You're typically going to find carbon or silicon in your central atom position. Those are the only ones that can make enough bonds to do this. The other one typically has just 1 dot, so it can link into that central atom. Again, draw the middle one first. And then link in your others. Draw this as neatly as I can because the board is not aligned very well. See, when we link all those chlorines up to the carbon, we have no choice but to use up all the electrons. So whenever you have 5 atoms, the answer here is always no. And we look back at our table, we can see that there is only 1 line for 5, and it says no. There's no yes here. You can't have a yes there. The bond angle is 109.5 degrees. It's called tetrahedral. Looks like this. It's basically the pyramid with another one stuck on top. Again, put the center atom in. Your 3 on the bottom and 1 on top. Looks something like that. 2 atom ones, straightforward. Because again, a 2 atom one has only one option. We go back to the table. There's only one row for the 2 atom molecules. They're always going to be linear. There really is no middle atom, so the answer for a 2 atom molecule is always no. Since there's no middle atom, there really is no way of having any unshared electrons. There's no middle. Just the covalent bond there in the center. Again, that's linear. 180 degrees whenever it's linear. And just put your atoms together in a straight line in a row. One more on here. It's another 3 atom one. We've already done a couple of those. This one's a little weird because it has a metal in it. It has beryllium. Beryllium looks like that. Fluorine. And again, I'll draw this as best I can. My board's not very well aligned. Beryllium has 2 single dots. The fluorine has just 1. So the beryllium has to go in the middle. I'm going to put my dots here and here just to fit that fluorine in. I'm a little crowded here with what space I have available. So I'm going to twist it a little bit so it fits. There's 1. There's 2. Now don't let that bent shape fool you. When you look at that central atom, the beryllium, we have circled all its electrons. So there are no unshared electrons there. This, like the second one, actually not the second one, like the first one, is linear. 180 degrees. Arrange everything in a row. Single lines because we have single circles between the D's and the F's.